Hello everyone, welcome back to another episode, and episode 1 of MINETECH. Yes, MINETECH. Now, when I was choosing the name for this series, I was like, oh, MINETECH sounds nice. Wait, it sounds familiar too. I bet there's a billion servers, a billion series by name MINETECH, and I was too busy to research it all. So, yeah, YOLO. And so in this episode called Circuits, we're going to be talking about all the different types of circuits in Minecraft. Before we do that, what is this series? This is episode 1. You have no idea what I'm going to be doing in this series. Well, in this series, I'm going to be taking my knowledge about computers, which is, I'm not bragging or anything, but I think quite a lot, and combining it with my Minecraft redstone knowledge, which is still not bragging or anything, but I think is quite a lot, not your average noob. But yeah, and so I'm going to try to recreate all the parts of a computer in Minecraft, assemble it all together, and hopefully make a working Minecraft computer. Yeah, people have done it, and when I see their videos, I can be, oh, I know what that is, I know what that is, I know what that is, I do not know what that is. Screen is probably the hardest bit for me. I mean, you can make it work, you can get it in memory, but to make the screen, I don't know how to make the screen. I'm going to have to do some research on it. But, so, all of these gates, logic gates, circuits, whatever you want to call them, clocks, redstone decorations, I knew how to make, but I didn't know the names, so I had to research a bit, and I got the names. So, I also laid it out in a very interesting manner. So, we've got your very simple, bit more complicated, but nothing you can't understand, very simple. And so inverted. So these do the exact opposite. Well, the circuits are the same, but the output, the redstone that comes out, is inverted. Now we got the bloody complicated one and the bloody complicated inverted one. Yeah. Now we got the memory. This is memory, which we're gonna be talking about memory RAM in the next episode, I think. Hopefully. We've got miscellaneous, but it's quite close to the one. And here we got the forever alone one. Forever alone. Because it's creating so much noise and lag. So, yeah, let's get started. So before getting started, we're gonna go to our OT gate, the simplest gate there is, and explain the parts. So, in a redstone circuit, there is the input, the output, there is the wiring, and the structure. So input is the thing that redstone goes in, or you can manually move like this lever, and the output is what comes out of the circuit. So you see, very simple, you've probably used this a billion times. The wiring is redstone, torches, repeaters, comparators, pistons, and the body is where it's built around, which is the stone block. The sign is not part of the circuit. It's just so I can remember what it's called. So the OT gate, probably the simplest ever. Now, how this works is a bit obvious. It uses quantum interstellar time and space from the power of the sun and recreates a new range fluctuation in space and time and spawns a redstone block. Yep. So yeah. Next, I'm not gonna go with this one. This is complicated. So this is like a shut up. Yes, you. I'm talking to you. Shut up. I'm gonna have to break it right now because I'm gonna get annoyed. Sorry. I'm staying your friend forever alone circuit. So yeah, this is an OT. This is an OR, which means that either one of it's got two inputs. Well, it can have multiple inputs, but our example is 2. So you can have another lever here, and another lever instead of a stupid sign. I know. And so only one of its inputs has to be on for the redstone signal or the output to be valid and light up and be very pretty. Yeah. These look like blood. Minecraft wires are very grim. Next, oh yeah, we'll go back to this. This is a bit complicated. So you should know that if a redstone torch doesn't have any power, it stays on. But when it does receive power, this is our NOT gate, inverse of that. See, it's got an N front. So when it does receive power, which it is receiving, it turns off. So this is a AND gate, which means that both of its inputs, or multiple inputs, have to be on for the output to be on. So let's see what's happening. If we switch only this one off, it will switch its redstone torch. But this redstone torch is still switched off because this one is still powering it. Same story if we inverse it. This one's off, but the redstone dust here, who's turning off this one, is still receiving power from this little bastard. But if we turn both off, both torches aren't giving at all any power to this redstone torch, which will naturally turn on and give yourself an output. So that's, yeah. I actually quite like this circuit. It's simple, but very effective. There's a way of making this using pistons. Well, I guess I can show you now. I don't have a piston in my inventory. I don't need. Why not put current command? Piston, piston, but anyway, let's put it. So, yeah. Probably a simpler version of it. So, let's say you got your red. I just hit multiple buttons there, and I hope I didn't press the stop record. Nope, I didn't. So, yeah, let me just put this. I'm sorry. I didn't. Let's turn this. Whoops. Oh, God damn it. What button? Okay, good. Minecraft controls confusing gamer since, alpha. No, alpha, yeah. As you can see, right here, we have a, let's do this. Yet again, I'm very sorry for this inconvenience. But yeah, so let's have your redstone wire A and redstone wire B. And output is here. Nope, not there, here. And we got some buttons, which all work just fine. Only levers, darn it. Where did my levers go? Levers. I don't know how to pronounce it. The American way, or the British way, colorblind. Colorblind is the most British lever I've ever heard in my bloody life. Okay, right, so. Actually, yeah, I forgot the torch. Output, right, you see, only one is on. It's still no bloody power. No power is received, bitches. No power. I've done this wrong. I am very. Oh, God. I'm not going to give up. I am not going to give up. I shall continue to fight. If this is wrong, I'm going to get very calm. Yeah, not annoyed at all. So, anyway, yes. One redstone input on, nothing happens. The torch stays off. The other one, well, nothing. Oh god. Oh, it's not. Yeah. Anyway, okay. Screw that. Wait. Okay. Yeah, we're back to here to the inverse. So, just got a redstone torch here. Here we've gotten rid of the redstone torch actually. So, even if both levers need to be off for the signal to be off. This should be called and that one should be called AND, but I'm not really telling you. This one's simple. Yep. Now before we tackle this, which is the XOR and the XNOR, which, to be honest, I haven't quite grasped the full concept. They both look very complicated, which makes me look very clever, even though I'm pretty stupid with these two. Right, so I'm gonna experiment. So if we got one off, it stays on. Oh, I get it. If this one's off, this one's on, so it does the reverse, vice versa. Yeah. And if both are off, okay, if both are off, the signal's off, and if one of them's on, the signal's on, and if both are on, the signal's off. Oh, so only one of these can be on for the signal to be on. That does not make sense. Anyway, inverse, we'll just put a redstone torch here. Now, what should we tackle? Oh yeah, should we tackle the annoying one? Okay, I'll boot her up. Oh, it's not making any noise. I know it is. So this is a rapid pulsar. You've probably heard about clocks in Minecraft. If you, not the golden clock, but the loop clock with repeaters. If you haven't, you should probably not be watching this video because we're going to be tackling some pretty complicated stuff. But this is a rapid pulsar. Another way of making these rapid pulsars is by getting a hopper. Yeah. Get a hopper and a comparator. Oh, that's why I had a comparator in my inventory. I understand. Everything is clear to me now. So unless you know how hoppers work, right? Okay. So what we're going to do here is break this one now. Hoppers look weird. So what's going to happen? The item's going to go from here to here to here to here to here, guys. So demonstration is throw a hopper in here. A hopper in a hopper in a hopper. So you see it's pulsing from this one to this one, and a comparator has the power of sensing if it is in that comparator. See, it's pulsing on and up and on and up. Yeah. So it isn't very powerful. You can barely shoot out little power because it's only one item. It's only one item. If it was more, so just try to repeat it here. And there we go, a very powerful redstone wire ready to go mad with. So this is a one-tick pulse, which it would be. Is it one-tick pulse? I'm not sure. No, two-tick, because a comparator is a two. Comparator is receives actually one tick. It powers up redstone wire, but it does actually last one tick. Otherwise, people would use it to their advantage to make minus one tick clocks, which will crash Minecraft, or just burn out the torch, which they do now, but they used to crash Minecraft. And got this one to get more power. Anyway, yeah. So can I kill this guy? Yes, I can. So here we've got. Let's start with the repeater. Now, yeah, you'll be like, no repeater is one of these. It's one of this work. But yeah, this is a modular version of it. So as you can see, it is off at the front, and it is off at the upper in the front, and it's on at the upper. And this is a 2-tick clock. And the reason, so you could either just do that, which I do that. But if you want to have multiple leads coming out or something like that, it's better to use a extended version of the repeater. Just for I'd show you that, because we are going to, I think we'll be using some of those in the RAM, because we're going to have multiple information leads, data. And so to our Arsenal memory cell. So I didn't know why I didn't want to put this the next episode, which memory episode. We're going to be building RAM. Next one will be ROM and stuff. And so the Irish Noir. No. So this is amazing because it uses buttons. So right now this one's on, and this one's when you press the button, this torch will be like, hang on, that one's on. Let's turn on. I want to copy him. It'll be like, on's boring now. Let me turn off. But then they'll change. So this is the very ever simplest data transversion or binary, on or off. If this one's on, then you press the button, it will make the on signal there. So that is, I don't know how much memory this is. I think it might be 1 bit, which is either on or off. Like when you see 8 bit, it means you've got 8 of these, and all the separate combinations of 1101 or something like that could make different variables. And I don't know how much is a letter. I'm pretty sure it's a 4 bit. I'm not sure. Don't quote me on that. Don't quote me on that, sure. Next, we've got another version of it. So, RS NAND and RS NOR. And if you remember NAND, which is this circuit over here, it combines these two together. While this one combined the RS with the NOR, and the NOR is that one. So this is just basically the opposite of that one. Yeah. So, I hope you enjoyed this video. Maybe it was a bit boring for some. You were hoping to build a dream Minecraft Apple computer and become rich and make it richer, T-blocks. But, next episode, we're going to tackle RAM. And after that, RAM access memory. That ROM, so we can actually read the damn RAM. Ooh, that rhymes. Damn. RAM is damn. And after that, I had no bloody idea. We're probably going to keep on the theme of memory, and then we're going to go to processing, and then we're going to go to wiring it all up. And finally, with a heavy heart, I say we're going to be tackling screens, which I am probably going to need a lot of help with. But anyway, thank you for watching. I really appreciate it. Please subscribe and like if you want to see more of me. And yeah, I know it takes me a long time to record this because all sorts of school and homework and programming and stuff like that. But Thank you for watching.